Hi, welcome back to engineering drawing scales. We are going to see the scales here today. Hope you are enjoying the previous lectures on engineering drawing. If you want to learn this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create more such videos in the future. Now, let's jump right into the topic. Let's see what the scales are. So here, the scales means we use a scale to measure some lengths, right? Generally, we use it. It is some 30 mm, 30 centimeters length, having centimeters and millimeters on it. But suppose I want to have a drawing of very big dimensions. Suppose it is in meters or kilometers. We want to measure the distance between two cities on a map. For that, we cannot have a scale of which is in meters or kilometers length. We have only a small limited size paper or sheet. So for this, we construct a scale. We use a scale of different nature, which is used to measure lengths of any size, right? Maybe in meters or kilometers or whatever it is. So these scales come in three varieties: plane scales, diagonal scales, and vernier scales. We'll see one by one, right? Coming to these scales, one important parameter we need to understand is the representative fraction. Representative fraction means generally we call it as RF. That is, suppose if I draw a line of 1 centimeter long line here, right? The representing length which you are drawing on the drawing sheet is representing how much originally, right? The original length is taken in the denominator, and the length of the line which you are drawing on the drawing sheet is taken in the numerator. The ratio is called RF. It doesn't have any units. Okay. Now let us see with an example. We construct a scale of 1:4 to show centimeters and long enough to measure up to 5 decimeters. Here we are given the RF, that is a ratio. Meaning is, if you draw 1 unit length here, that indicates 4 units of original length. Now, it is in showing centimeters and has to measure 5 decimeters. Let us see how to draw it. The RF is given directly, right? Now, the maximum length, it is given. We have to construct, we have to calculate the length of the line which you are going to draw here to measure that 5 decimeters. To get that, we call it as length of the scale. You get this by multiplying the RF with the maximum length. RF 1/4 into 5 decimeters. 5 into 1 decimeter is equal to 10 centimeters. So convert them into some measurable units with our scale, that is centimeters. So simplifying this, you get 12.5 centimeters. Draw a line of 12.5 centimeters and make it a small rectangle. Construct a rectangle of 12.5 centimeters here. Okay. Maybe taking by 5 mm height for this scale, right? To give a feel of the scale or regular scale. Divide this into 5 decimeters. This is a 5 decimeters length. Representing this length, even though it is 12.5 centimeters, it is representing 5 decimeters. So divide this into 5 parts. That means each part is representing 1 decimeter. So mark these points as 0 here, not like on our original scale. Generally, our scales start 0 here. But here in this case, we mark 0 here at the first division. So 0, 1, 2, 3, like this. Each one is representing 1 decimeter. So decimeters are written here. Now, coming to the left side, we are left with 1 unit. This is also equal to 1 decimeter. This 1 decimeter, okay, is equal to, say, divide this into next smaller units. Like 1 decimeter is equal to 10 centimeters. Divide this into 10 equal parts. We get 10 parts here. So each one is representing 1 centimeter. Because this is 10 centimeters, each one is representing 1 centimeter. So like this, we get decimeters as well as centimeters. Now, I want to show 3.5 decimeters using this scale. 3 decimeters here from 0, we have 3 decimeters here, right? And in the left side, we can have 5 centimeters or 0.5 decimeters. So draw extension lines at these points and draw a dimensioning line here, show the length 3.5 decimeters here. So like this, we can construct the scales of any length and we can measure these scales up to the maximum dimension which you are given. So this is one. Next, let's take another example. Construct a scale of RF. RF is given. Here you are asked to show meters and decimeters. Its length is 6 meters, right? And we are going to see. RF is given directly. Maximum length is 6 meters. So length of the scale 1 by 40 into 6 into 1 meter is equal to 100 centimeters. So simplify this, you get 15 centimeters. So 15 centimeters long line is drawn here, right? To give a feel of a scale, draw a rectangle. And now divide this into how many parts? 6 parts. So divide this into 6 equal parts. Each one is measuring 1 meter. Now, I start with the 0 here at the first division. 0, 1, 2, 3, 4 like this. Each one is representing meters. So write meters here. Coming to the left side, divide this into 1 meter. This is representing 1 meter. 1 meter is equal to next smaller division, that is decimeters. 1 meter is equal to 10 decimeters. Divide this into 10 equal parts and you get, mark this from 0 towards left side. 5, 10. Now, we are able to show decimeters and meters here on this. So, I want to now show 4.6 meters or 4 meters, 6 decimeters on this. 4 meters and 5, 6 decimeters here. So, this is 4.6 meters. Like this, we can draw the plane scales. Let's take another one. RF is given here. You are asked to show kilometers and hectometers. Its maximum length is given 12 kilometers. Let us see how to draw it. RF maximum length is given. Find out the length of the scale. RF into maximum length 12 kilometers. 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeters. So simplifying this, you get 15 centimeters long. Draw a scale of 15 centimeters here and divide this into 12 equal parts, right? Divide this into 12 equal parts. Each one is measuring kilometer. So mark from here 0, 1, 2, 3 like this, write kilometers, right? And the left side, this is also 1 kilometer and this is equal to 10 hectometers. So divide this into 10 equal parts. Each part represents 1 hectometer. Write hectometers here. Now we are showing kilometers and hectometers. Mark 8.3 kilometers on this. 8 kilometers here and 3 hectometers. So that is nothing but 8.3 kilometers. Okay. Now, suppose the RF is given as 1:5 to show decimeters and centimeters and to read a maximum of 1 meter, right? Take RF 1/5 and maximum length 1 meter. Length of the scale RF into maximum length 1 meter is equal to 100 centimeters. So 20 centimeters is the length of the scale. Draw a line of 20 centimeters, right? Form a rectangle. Divide this into, this is 1 meter, right? This entire length represents 1 meter. So how many parts to do? Here is a question. We are asked to show decimeters and centimeters. That's why I'll show this entire 1 meter is equal to 10 decimeters. Divide this into 10 equal parts. Okay? 0 from here, 0, 1, 2, 3, up to 9. Each one is representing 1 decimeter. So write decimeters here. Left side, from 0, this side, this is entirely 1 decimeter equal to 10 centimeters. Divide this into 10 equal parts and name them and write centimeters here. So this is our scale. Now you can measure 6.7 decimeters on this. 6, right? And 0.7 decimeter means 7 centimeters. So 5, 6, 7. So this. So that is nothing but 6.7 decimeters. Clear? Next. Here, the RF is not directly given. RF is indirectly given here. A 3.2 centimeter long line, which we are drawing here on the scale, on the drawing sheet, is representing a length of 4 meters. That means original length is 4 meters. Now we have to calculate the RF. How? RF is equal to 3.2 centimeters by 4 meters. But to convert this into RF ratio, convert this to same units, centimeters, right? 1 meter is equal to 100 centimeters. Convert it into same units, centimeters and centimeters goes, and you get a, simplifying this, RF is 1:125. Draw it. Now, you have to measure a length of 25 meters. So maximum length 25 meters. Length of the scale, RF into maximum length. Convert this into centimeters. You get 20 centimeters long line. So draw a scale of 20 centimeters length here. How many parts now? Or they have to divide it into how many? You can divide this into 25 parts, but dividing this into 25, each one will be small. That's why better divide this into 5 parts. I divide this into, each one is 5 meters. So divide this into 5 equal parts, right? And you show 0, 5, 10 like this meters here. Now, this is also representing all our equidistant points, right? This is 1 meter. Divide this into, right? This is 5 meters. This length is 5 meters. Divide this into 5 equal parts and name them from 0 towards left. This is also representing meters. That is the beauty. Here, it need not always be the next smaller division only. So here meters, but 5 meters, each one is 5 meters. But here you get a single meter, 1 meter. Now, I want to show 17 meters. So how? 17, we have 15 here, right? And 2 here this side. From 0, you take 15 meters on the right side and 2 meters on the left side. Put together, you get, this line should be drawn here at 15, right? 15 plus 2. So drawn a line here from here to here. This is 17 meters, right? Or if you take 10 here, 10 plus 2, 12 meters only. This is representing 12 meters. Right. Now, so we have seen the principles of scales, and in the next video, we are going to see how these plane scales in British units. Hope you had understood this topic, and if you have any queries or comments, please do send in your comments, right? You can even send your suggestions too, please. Thank you.